Okay, good day everyone. For this chapter, we are going to talk about basic set theory. No, particularly we will talk about uh, sets and operations of sets. Yet, the rest of the topic, like relations, functions, and binary operations, will be discussed in the next video. Okay. For this lesson, what we are going to do is that number one, we are going to um, recognize some set notations and some set symbols, as well as we are going to perform operations related to sets. Okay, what is a set? Okay, a set is just a well-defined collection of distinct objects. So here are some examples. So you have some goods, a set of goods. Then you have a set of fruits. You also have the set of uh, shopping mall items here. Okay, we also have a sala set, so a table set, and a shoe collection set. You also have a bag set. Okay. Okay, you also have a Rubik's Cube set. Okay, in the set of numbers, okay, we can also, in the set of numbers, we can also categorize them, no? And the common one is the set of natural numbers, or we call them counting numbers. Then you also have the integers. Integers are the set of natural numbers, 0, and the negative of the natural numbers. So there you go. Those are the examples. Then the set of whole numbers, so natural numbers plus 0. Okay, so you have some examples there. You also have the set of rational numbers. So any number written in the form of m over n, such that m and n are integers. So in other words, these are fractions. Okay, so rational numbers are fractions. So here are the real number systems, no? Then if you combine rational numbers and irrational numbers, this comprises the real numbers. Okay. Okay, let's proceed with the set notation. So there are 3 ways that we can write our sets. But before that, let's talk about some notations in sets, no? Okay, we represent A as the set, no? That's the name of the set. We denote that as a capital letters. Then all of those objects enclosed in the braces are called the elements of the sets. Then the number of elements, so you have, if you try to count the number of elements of the set, we have 4. We call that as the cardinality. So we'd say the cardinality of set A is 4. Then since 3 is found at A, we could say 3 is an element of A. So we denote that symbol as element. And since 7 is not found in A, we could say that 7 is not an element of A. And take note of that symbol, no, not an element. So there are 2 common methods in describing a set. We have the rule method. So it uses a phrase that describes a property of the set, enclosing it by a pair of braces. So Rule method examples. We could say the set X is where X is a vowel of the English alphabet, or you could say a set Y where Y is a counting number, or you can say a set C such that Z is a college of a USDP CDO, and so on. So you can also list it uh, through a Rooster method. So Rooster method is just simply enumerates or lists all the elements of the set and enclose it with a pair of braces. So it's say for letter A, no. So for example, for letter A here, if we convert that to Rooster method, we can have A E I O U. For letter B, we can say a counting number, then we can write it as 1, 2, 3, and so on. And if you write for letter C, the equivalent user method for that one, we have this one, CSM, COT, SEA, CST, and so on. Okay. Okay, D there. Okay, what is diva? P is a dog that can fly. You know? And we know that there is no dog that can fly, right? And we denote that as a set with no elements. We call that as an empty set. No, we call that as an empty set. Okay, let's try to unlock some familiar some terms here. We can say set A is a subset of B denoted by that symbol if every element of A is also found in B. So if we could say if every element in A is found in B, we could say that A is a subset of B. And say, for example, here, if we could say we have set A and set B, take note that all elements in B are found in A. You know, all elements in B are found in A. So we could say that B is a subset of A. On the next example, we have set C and set D. And we all know that D is found in set C. D is found in set C. We could say that D is a subset of C. Okay, let's do this exercises here. Just state if it's true or false. Is D a subset of A? Okay, let's check if all the elements of D are found in A. So 2 is in A, 4 is also in A, 6 is also in A. So therefore that is a true statement. Okay. Next one, is A a subset of D? Okay. Since okay, 1 is not in D, no? So we can say that A is not a subset of D. So it is false. No? So not all elements in A are found in D. So that statement is false. Next one, is B a subset of C? Let's take a look. Is 2 found in B? Okay, no. So not all elements in B are found in B. So therefore that is a false statement. Okay, is a set containing 2 in C a set containing 2? That is a set with one element. Okay, is 2 found in C? Yes. No? So therefore that is a true statement. Next one. 1 is a subset of A. Okay, 1 there, it's not enclosed in braces, right? 1 there is not enclosed in braces. So therefore it is not a set. So therefore that is not a subset. Okay, that is false. Take note, no? When you are going to write a set, it should be if it's in the elements. It should be enclosed by a pair of braces. But if it's not, it's just simply an element. Okay. Okay, let's do some. Okay, let's proceed with the operations of sets. No. First operation is the intersection. The intersection of two sets A and B, denoted by that symbol, is a set of all elements that belong to the sets A and B. All the elements belong to set A and B. Okay, so intersection is all the elements found both in A and in B. So they share a common element. So that is the intersection. So in notation, we say A is a set in A is intersection B. It's just simply the set of X such that X is found in A and X is found in B. So let's say, for example, if you have set A, 2, 3, 4, and 5, and 1 B for 1, 3, 7, and 8. So the intersection will be, okay, what is their common element? So we have 3. So their intersection is a set containing 3. Okay, say for example here, so what are the sets found both in C and D? So we have 2, 4, and 6. So therefore, the intersection is just the C 2, 4, 6, or the set D itself. Okay, the intersection of A, C, and D. We know the intersection of C and D is 2 and 4. So what is the intersection of A and 2, 4, 6? No, 2, 4, 6. Yeah, correct, no? So we have a common of 2 and 4. So therefore, their intersection of these three sets are the set containing 2 and 4. And if you have the intersection of A, B, C, and D, okay, intersection of A and B is 3, and intersection of C and D is 2, 4, 6. Is there a common element between the two intersections? There is none. Okay, so since there is none, so we have an empty set. Union. So when we say union of two sets, denoted by that symbol, it's a set of all elements that belong to either A and B. So it's either A and B. It's found in A, or it is also found in B. So in the descriptive annotation, we have that symbol that is set of X such that X is in A or in B. Pwede sa A, pwede sa B. So for this case, we will just simply combine all the elements for both. We will combine all the elements for both two sets. Say for example, set A for 2, 3 and B 1, 3, 9. So the union will be, so union. Well, so we are going to enclose all of them, all the elements uh, found on A and found on B. So the union will be 1, 2, 3, and 9. So say union, all you have to do is to join all the elements. No, all you have to do is to join all the elements. Let's say for C and D, so 1, 2, 3, 4, 5, and 6, and D is 2, 4, 6. Okay, if you join this one, these two sets, the union is just simply 1, 2, 3, 4, 5, and 6, or just simply the set C itself. Okay, if you join the union of A, C, and D, since union of A, C, and D is 1, 2, 3, 4, 5, and 6, and A contains 2 and 3, so it's just simply 1, 2, 3, 4, 5, and 6 are just simply set C. If you join the union of union of A, B, C, and D, we know that union of A and B is 1, 2, 3, and 9. And for C is 1, 2, 3, 4, 5, and 6. So join all of them together. Okay, we have 9 there, so we will just simply add 9 to the elements. Okay, so those are the union of the 4 sets. Okay, there is what we call the universal set. Okay, the universal set is a set which contains all the elements of or objects of other sets under the consideration. Let's say, for example, A is 2, 3, B is containing 1, 3, 9, and also for C and D. The universal set will be, we could say, the set counting numbers from 1 to 10. Okay. Anyway, in most of the problems, the universal set is always being defined. I say in this in the USTP students, no. So if let us say we define the set as the all students in the university. So the the universal set will be all the students found in USTP. Okay, next is the complement of the set. Okay, the complement of the set. We denote that as A prime, no? Okay, these are the set does not belong to the universal set but does not belong to the set in A. So we can write the description. A prime, or the complement of a set, is the set of X such that X is not found in A but it's in the universal set. No? It's in the universal set but not in set A. Let's say, for example, if you have the universal set as the set of counting numbers from 1 to 10, and we have A, set A is 2, 3, 7, 8. Okay, then the complement of A, so what are those elements not in A? So we have 1, we have 4, 5, 6, 9, and 10. So the complement for A is 1, 4, 5, 6, 9, and 10. And if for B, let's say 1, 3, 4, 7, 9. So what are those elements not in B? We have 2, we have 6, we have 8, and 10. So we have 2, 5, 6, 8, and 10. So those are the answers. Let's say the complement of A and B. So what is the union of A union B? So if we join A union B, we have 1, 2, 3, 4, 7, 8, and 9. So what is the complement for that one? So what are those elements that are not found in both A and B? So we have 5, we have 6, and 10. So the complement of the union will be 5, 6, and 10. Okay. There is also what we call the set difference. No? Set difference, we can say if we have A minus B, no? A minus B. So those are the elements found in A but not in B. You know? Those are the elements found in A but not in B. So we can say if for this example, if we have 2, 3, 7, 8, and 1, 3, 4, 7, 9. So if we take A minus B, the answer would be 2 and 8 because 2 and 8 are not found in B. If you have B minus A, no, B minus A, so set whose elements in B but not in A. So what are those elements in B that are not in A? So we have 1, 4, and 9. So if we take B minus A, that is 1, 4, and 9. Okay. The rest for Cartesian product and so on, I will discuss them to our next video.